Thank you for coming for our talk. This talk will be 2 presentations. Probably not enough to have, like, the research itself is not enough for full 45 minutes, so we combined forces and made it into 1 presentation. We're going to talk about WSL, and I'm going to talk about staying under the radar when using Linux, compromising Linux host. So three quick things. First of all, for my talk, there won't be any code. It's just stuff I learned, and English is not my first language, so sorry, I'm nervous. I'm going to speak quickly, and I hope you understand it all. So, a quick one about me. Senior red teamer at Mandiant. I've been to the industry 7 years, quite big on Twitter. I like Twitter, Twitter addict. I've been to the military for 3 years, so is Max. And no, I wasn't 8200. I didn't do a uni degree, so I hope I can inspire people who have not done uni degrees and want to get into the field. I'm a jack of all trades. I'm not specialized in malware development or anything else. I like to do everything. I like to know everything. So if you want to speak about red teaming or anything in security, I would like to speak to you as well. So that's Max.
Hi, so I'm Max. I'm also on the Mandiant Red Team, part of Google Cloud now. I've spent about 5 years in security and then 1.5 of those with Mandiant. I do have some previous experience in security, sort of physical and technical, public and private sector as well. And my job role is red teaming, purple teaming, same as Idan. That's it for me, really.
Yeah. You will see on this talk, we're part of APT66. It's the Mandiant code name for red teaming in Europe. So Europe only specializes in red team. That's mostly what we do. We barely do any pen tests. So let's crack on. So this talk is going to be about one of my jobs I've done, where a client asked me, can you come in and do a purple team on a Linux host? So most of our job obviously is interacting with Windows hosts. We have multiple malwares for Windows hosts, but we came to Linux. I was like, what do you use? Because a lot of time we just proxy our stuff, SSH into a host, a jump host, and do our thing, but we don't drop a C2. So that's what I've learned during this engagement, and hoping to explain to you. You'll learn more stuff about what you can do with Linux hosts. So the first thing to say, every time someone, a red teamer, says, let's compromise a Linux host, they're like that. EDR on Linux doesn't do anything. And that's what I thought, but going to be a bit of surprise there. So let's see what I've learned during the talk, during the engagement. Let's start with the basics. What was the goal of the engagement? It was a purple team. The client asked us to it provided us a VPN into a network environment. It was the contract, as a contractor, a VPN into the environment. It was a SIM bridge. There's no phishing or anything. We just start directly from access to the host itself. They provided us with 2 Linux hosts. Both of them had different EDRs. I can't say names, but you might see some hints during the presentation. And we had 2 weeks of testing. It's worth noting that those operation systems were quite old, running kernel 3.10, which is from 2013. So a lot of modern stuff, modern protections, or modern techniques don't really work on those old OSs. So let's start. If you're thinking about dropping a C2, command and control, into a Linux host, probably your first thoughts are Mythic or Sliver. Because it's a purple team, we can use our internal Mandiant command and controls because it's proprietary, and obviously CoverStrike, stuff like that, are only Windows-based, so we can't use it. So my first question, I guess, how many of you know Mythic? Can you raise your hand? Do you know Mythic? It's a multi-agent, it's like the backend is already ready, but you only write agents to it, or use one of the already made agents. Sliver is also quite well known by Bishop Fox. Full-on, written in Go, it's cross-compiled because it's Go. So these are also options. The things I had to consider before the engagements are cross-compile. So like Go can compile to multiple different operation systems, or native is obviously if you write C, it'll be for Windows, or Bash for Linux. So stuff to consider, and obviously above all, has to be encrypted, has to be safe. We don't want to transmit sensitive data from a client to us, has to all be encrypted. So I guess my first question to be to you, no, second. Which one do you think I used? Would I go with Mythic or I go with Sliver? Let's raise hands for Mythic. Quite a few. Sliver? Okay, I think Sliver had a bit more hands. So, yes, you're right. So I had to go with Sliver. It's well known, so well abused by APT actors. It's a lot of feature rich, so it supports HTTPS, supports MTLS, WireGuard, quite multiple different operations, multiple ways to transmit data back to us. It also supports long pooling compared to periodically checks. The difference are that long poolings, we do HTTP connections and keep them alive, while periodic checks, it does check every so often, so interval. It uses Garble for obfuscation by natively, so it ticks a lot of our stuff. And on the left, you can see a page from Mandiant Advantage. It's the threat intel website that Mandiant use. You can see the threat actors, they are using it, and information about it. So let's crack on. Let's game day. Let's put Silver into the action. So first thing I do is obviously try to generate a payload. I'm generating a normal payload, so ELF, whatever. With -E, so that's evasion. -B just to tell you what side to communicate to, and then output that as a ELF, which you can see by default, it weighs 15 megabyte. A quite big payload itself without any modification to it, and I've not done any other modification to it. I just see if out of the box does it work or it doesn't work. So a quick reminder, we have two operation systems, two different antivirus. So how many of you think that this payload will bypass one or two antivirus? So first question is, didn't bypass anything? Raise your hand. No? Okay. Okay. Bypass one antivirus, one EDR. Okay. Bypass both EDRs. Okay. So quite a lot of hands. So first one didn't bypass any of them. Both EDRs caught these payloads, and didn't get any beacon back. Let's start to modify things, see if it works now or not. So this time, doing the same thing, exporting a file using the evasion, but this time the output needs to be a shared library, so .so file, which is the equivalent of DLL in Windows environments. So think about exporting a DLL, we have to call it, but it's fine. And that's it. The shared library itself is 17 megabytes, and I've not done any other modifications to it. How many of you think this bypass one of the antiviruses, EDRs? A few hands. Who think this bypass both EDRs? Yes, quite more. So it didn't bypass one of the EDRs, but it did bypass one of the other EDRs. So already win. We got half of our operations. We got beacon on half of our operation systems, but we still need to bypass the other one and get a shell. We got a shell with it. Beacon. I'm going to come back a bit later about if you see the end there, it says -- run it load. I'm going to speak about that part in a second. So next thing I try, raising the bar. This time, let's packet. Packet is make modification, compress it, or remove stuff we don't need of the binary, and we'll still keep it alive. So use UPX, or again, quite well-known packer abused by many APT groups is from, so shared library.so from 70 megabyte went into 9.8. So further down, probably quite good. If you look at UPX, I used the -9 there. It just means compress it better rather than faster. It goes from 0 to 9. So we are still trying to bypass one of the DDRs. Who think that was enough to bypass one of the DDRs? No? Think? Okay. So even with that UPX, it didn't bypass one of the DDRs. It's a good DDR. Apparently, Linux hosts, Linux DDRs are getting quite good. It's quite a well-known EDR itself. So again, raising the level, try to make modification, try to make it better. This time, obviously Sliver use garble as the obfuscation by default, but this time we're going to use GTFO, which is the Linux equivalent of LOBUS. If you know, LOBUS itself is it's the using common tools to execute your payloads that are already on the hosts. It's just other ways to execute a payload. So GTFO is the Linux version of it. Finding a way to execute shared libraries, load a library, we can use this Python, which work with 2.7 and work with 3. This way we just input our library and Python will execute our payload instead of us executing it directly. So trying that, raising the bar, who think that was enough to again gain a shell on this host? So not many hands, but okay, let's see. It did. It did bypass that fancy EDR. All you have to do is use a bit of getting other program to execute your payload. So now we got beacons on both hosts. And going a bit back to what I discussed earlier, just run it load, fast worth noting. Obviously, if you know DLLs, they have a function call. You have to call a function. So the same thing here with shared libraries. You just, with the standard function call in shared libraries is start W, which is here on the right. So we're just telling it start this function call, and then the payload executes. Well, on the left, it's already executed the payload from the beginning. We don't have to call that function. He knows where to enter and to execute the payload. So we got beacons, and I want to share with you from now on until the end of the talk about things I've learned. Because I think sharing this information is quite important. So the next parts will be just tools that I learned about during the engagement and other techniques, stuff which could be helpful for you if you're doing you're trying to compromise Linux host and you want to use something else, more stealth. So that's going to be custom toolings. When I started reading about all these malware invasions for Linux, all this cool stuff, most of them talk about memfed and how useful for it. And when I read it, and I'll give you a second to read it, it made no sense for me. Because in my head, everything in Linux is file. Like, everything is treated as a file. So processes are files, everything is a file. So that made no sense for me. It talks about how to execute code only in memory instead of RAM and doesn't back it up by a file. So I went and I spoke to someone and tried to figure out where was my mistake, where I didn't figure out. So in Linux, everything is not file. Everything is standard in, standard out, or standard error. So everything is started by streams of input and output. And that's, well, what my mistake and my misunderstanding. I didn't understand it. So reading more about memfed and how it does it, it creates anonymous file description, and I use that only in RAM. And it sounds amazing because it's everything we need. It's all in memory, no dropping anything to file. It's Linux servers are unlikely to get rebooted, so we're all good. And it's the equivalent of like syscalls and Windows. Sounds perfect. Let's dig a bit into that. And you can see here at the bottom, just it's that easy to execute it. Like, it's really easy to use. So how does memfed works? We can see here we create file description. It does the memory allocations, adds zeros into it, set the permission correctly, and then we can, it's quite easily, it's return the file description, and that's it. We got our beacon in memory. It's amazing. And this is how tools you can use to actually abuse it. Elf in memory does what it says on the tin, execute the binary itself into the memory straight away, or you can even download that into memory. And then ulxrfv is the system codes for Linux, and we can abuse that as well. There's a tool to do that. The problem with all of that is, if you remember, my operating system running kernel 3.10. memfed was not created back then. So, wasn't good for me, but hopefully it'll be good for you and helpful for you. And this is, I want to speak about more stuff I learned and how you can stay stealthy during those engagements. And first thing I learned, I knew about, but I never actually tried that, is there is actually buffs for Linux as well. So if you don't know what a buff is, a beacon object files, it's a way in Windows to execute cough files, which are basically a very raw file, and they're very stealthy. Because they're very stealthy, it's really hard to detect. So there's a Linux version for Linux. Great, that's what we need. Thank you, Trusted Sec. They created that library to execute a L file only in memory in a very stealthy way. So if you ever want to stay evasive or add that to your C2, that's quite a good add-on. It's quite cool. And by the way, this photo, I asked Google to create me a photo, and that's what it did of a buff, and that's what it gave me. Because our AI are not that good at images yet. And then other stuff I learned during the way is about distroless, and that's add-on from the last DEF CON, way to execute file when you don't have write permission, and it's read-only operation systems. Well, it's very common in Kubernetes to have pods which are mounted as read-only and not execute. So this is a good way to execute your payloads, even with those limitations. Other recommend looking at that YouTube talk. It's really cool. They do quite a lot of nice things in there. So, and next thing is worth noting is about linps. How many of you used linps in the past? It's quite a few hands. It's quite a well-known tool. And quite a lot. It's quite good for previous escalation, detect previous escalations methods in Linux. But most of us download the binary, execute it. What's a better way is actually modifying it, of course. And they actually give, in their repo, a way to build linps with only choosing what you want. So obviously, a big indicator of linps could be the logo, the ASCII art. So you can just easily remove it by using this builder on their repo. Don't execute every command, just set up the section you want to do and use that. The other thing worth noting are static binaries. There's quite a known repo with static binaries of like nmap, ls, anything that are statically compiled. They're used like, you don't need any other files. You can just drop this disk and use that tool. But all the tools from that repo that under D are from 7 years ago. So I would recommend you to create a CI/CD pipeline and just do it yourself with more modern tools and more modern versions of them. I think other things I've learned during this are about Dockers. I knew about Dockers, but my head was, well, it's like executing in a VM. I could just, if I have a Windows host and I have a VM, it's quite stealthy because the EDR mostly can't see into those VMs. If I spin up a Docker machine and execute all my commands from that Docker, it might stay under the rudder. But as you can see here in this photo, actually I was caught by EDR for trying to do that. So be careful trading there. One EDR did see into my Docker files, EDR didn't see it, so be careful. That's me, just trying to execute limps with a modified version and see what I can see into the host, because it also has range of things. And next slide is for the blue teamers. So what can you do? You're a cool blue teamer. What you can do to actually detect those environments, detect those things, is look at up armor, which is the equivalent of app locker in Windows, or CE Linux, which is permissions ACL's way to stop stuff from executing, or set correct permissions. Now, don't forget the logs. Those are very important things. So if you're a blue teamer trying to defend against C2, I highly recommend looking at those. I feel like my talk is very sporadic. It's a lot of stuff, but I just want to pass stuff I learned during this engagement to you guys, and hope you'll find it interesting. Other things I've noticed during the engagement is, well, in Windows hosts, it's quite easy to determine what EDR you're coming against. There's many C# tools, there are many buffs to detect those. In Linux, there's no repo with all the EDR's names and the services they use, so I started that. If you find any other EDRs on there, I'll happily accept PRs. But that's a good, quite easy way to detect what EDR you're coming against, and what you can do or what you can do. You can obviously try go home and install your own lab with that EDR and try that. The other thing I didn't know about is Mighty Attack for Linux. It's not just Windows, there's only a Linux version, which you can set ADPs and align it in your report. And last few things are, if you want to create your own lab, if you want to go home and practice those Linux malware invasions, this is quite good stuff to go for. And again, things that surprised me is Sysmon for Linux or Progdam for Linux. They're quite well known in the Windows areas, but you know they also exist for Linux. So go and try, go and practice, and go sharpen your skills. If you want to learn more, this is a good link for tools that are, or tools or tutorials about how to create malwares for Linux. And last but not least is what the client learned from this is we had daily calls to discuss the TPs, what we tried, what we didn't try. They wrote new rules for the EDRs, and we increased our detection rate. The client came happy. We increased our skills. We learned from this. We sharpened we next time could be a lot better. And client was happy. That was my part of the talk. Now we're going to Max, who's going to talk about WSL.
Thanks, Idan. Hello, everyone. So we split this talk into two. First half, Idan's just presented there, and I'm going to present a little bit on leveraging Windows subsystem for Linux to bypass modern detection when we're operating in kind of modern environments. So we'll run through a basic introduction of WSL, how we can install it, common malware we see which leverages WSL in the wild, dubbed bashware, some use cases or ways that we can abuse this as red teamers or in offensive security, some visibility and telemetry, and then just some other considerations and points of interest at the end. By way of a quick show of hands, does anyone really had much experience with WSL in the past? Okay, cool. So this is kind of aimed at all levels. I won't be going into huge detail in individual sections. I'm trying to get a kind of coverall to kind of convey how it can be useful for us in certain situations. But by all means, it's not an in-depth look. So there's not a huge amount of coverage or attention in the public eye for WSL. Threat actors have been known to use containers or VMs to their advantage. There's been a few real-world cases. If you search the internet, you'll find a couple of blog posts documenting this, but it doesn't seem to be a common occurrence. It tends to be those few cases. And this is perhaps because there are some prerequisites, some constraints. It's quite frankly, there are easy ways of getting the job done if you're trying to stay under the radar and execute malware on Windows hosts. But it is useful in its own right. So the main goal of this presentation is just to explain how it can be useful for us. So as a basic overview, Linux environment directly on Windows, that is kind of as basic as it gets, but it brings the advantages of Linux to Windows. It's installed by default on Windows 10 and above, so that's including server editions, Windows Home and Pro, and although it's installed by default, distributions won't be installed by default, and that requires administrative rights to install a distribution, although those distributions, once installed, can be accessed by low-privileged users from the Windows environment. And there are a couple of differences in versions. So the main difference, the main versions 1 and 2, which we'll touch on a little bit later on. But version 1 uses a translation layer. It effectively emulates the Linux kernel, whereas WSL version 2 uses virtualization. So version 1, it uses Pico processes. I won't go into huge detail here, but it's effectively a minimal process without some of the common components of an NT process, so no PEB, threading, etc. And they rely on Pico providers. So there's two here, lxss.sys and lxcore.sys, and those Pico providers act as Windows kernel mode drivers to emulate the Linux kernel. So lxss.sys will translate Linux syscalls into Windows NT calls, which will allow us to run unmodified ELF binaries on Windows. Version 2 then, the main difference here is the architecture change. So version 2 uses virtualization, and that's on the Windows native Hyper-V. So you don't need to configure anything else. You don't need to install VMware or VirtualBox. It just runs on Hyper-V, and it's built in. And this means that it has a complete Linux kernel, rather than acting as a translation layer, as it does in version 1. Performance improvements in version 2 mean that you get faster code execution, less memory used, among others. And there is a difference in the logging capabilities in Windows, which we'll touch on a little bit later, between the two versions. So we're going to talk about installation. This is kind of twofold, so you can either use this in a test environment to set up if you wanted to install WSL and have a play about, or if you come across a host on a red team, a Windows host where you have local admin rights, then you can use this method to either install a distribution, or if you need to try and enable WSL to start with. So the differences in versions, version 1, you probably won't be using this, but if you wanted to, you can provision your Windows VM or your Windows workstation, then enable WSL version 1 in Windows features, and then you're free to install a distribution. We can list distributions to see if any are currently installed or whether our installation has been successful. I'll show you how to do that in a second. And in version 2, the only real difference is to enable virtualization, and that's also done in Windows features. So these are the basic steps here. Hopefully that's clear. We can enable using DISM. Again, enable virtualization doing the same, and then we can install a distribution with the -D flag to name the distribution we want to install. We can also list those. There's like an online repository. You can install these from the Microsoft Store or via the command line. And post-installation of a distribution, for both versions, you'll need to reboot. And then we can list our distributions with the list flag shown at the bottom there. Bashware then. So you might be asking, has it really been used for malicious purposes in the world? Apparently it has. If you do a search, there's a little bit of information out there, but this is the term commonly used to describe WSL malware on Windows. There have been a few variants in the wild, mainly using Python. Nothing specifically or especially advanced, mainly using Python and C types. But there have been some cases of cross-platform compatible malware targeting WSL. So why could it be useful for us as red teamers on our engagements? We're going to touch on why we care, effectively. So a couple of the capabilities it affords us, we can execute commands through WSL, so either on the command line as a one-liner, or we can drop into a shell interactively and execute commands that way. We can execute Linux binaries. So how is this useful to us? There are some significant advantages to executing Linux binaries on Windows, which we'll touch on in a minute. And this may allow us to execute malware which can evade AV, EDR products. They might be more blind to Linux-based malware than Windows-based malware. This is not always the case, but it just kind of tips the odds in our favor. From the Windows side, WSL files can be accessed by standard Windows users, unless restricted. We'll touch on that later on, but usually no elevation required is required to read sensitive files on the Linux file system from Windows, which can be useful. And files are mounted from within the Linux distribution, so the C drive is effectively mounted from within the Linux distribution, and that can be found in Mount C. In version 2, there are some logging implications, which we'll touch on again in a minute, but effectively any arguments you pass to an interactive WSL2 session will or might not be visible in EDR or Windows event logs. You'll still be able to see the process creation, but command line arguments won't be visible. There is also this kind of using Linux binaries in Windows affords us possible application allow listing bypasses. So if we were able to run ELF binaries or file types foreign to Windows, it's likely that products like AppLocker may not be configured to block specific files like that. So, ELF files, bash scripts, and this could allow us to bypass these controls without having to use heavily monitored techniques like install util. And then lastly, we can call WSL. We can use WSL programmatically, and one of the ways to do this is to use WSL API provided by Microsoft. The link there at the bottom for the documentation. We'll touch on that a bit later on as well. So I wanted to give a flavour of how straightforward it is to take advantage of this for offensive purposes. If you imagine a scenario where we were dropping an MSF Venom Windows executable to a Windows host, just a straight exe, the fight is going to be fairly one-sided in favour of the EDR or AV products on the host. However, if we were to change that to an ELF binary, and we just generate a standard MSF Venom ELF binary, nothing special. You can see I've used no encoders, and I've not obfuscated it after the fact. How many people in the room think that is likely to get past a Windows EDR? Okay, a few. Well, it does. AV and EDR static detection. So no visible alerts. The file wasn't blocked. This is an up-to-date version of the AV as well. You can see I've tested that, I think, five days ago. Retested that. So if we were to drop that file to disk and we were to execute it in WSL, this is in an interactive WSL shell, then we're able to execute that. And obviously this is a very basic example, just popping Notepad, but it shows what we can do. So if we wanted to dig a bit deeper into that, then the process tree for execution can be seen in your EDR console of choice. On the left-hand side, you can see that the bash process has created Notepad, and we can kind of see the process tree on the right-hand side here. So it is visible, but no static or behavioral-based alerts have been triggered in the testing environment. And if we were to have dropped a Windows executable, the story would be very different here. This opens up our options on target during a red team, or even a pen test. If we're looking to bypass, security controls, Linux binaries can be very useful. It's only a very simple example, but if we wanted to get a bit more creative, and we wanted to, for example, get C2 command and control, we could use this in a similar vein. So in this example here, I've used Chisel, which is an open source TCP UDP client I'm sure most of you have heard of, uses HTTP over SSH. And I've compiled this, it's written in Golang, I've compiled this as an ELF binary, Linux executable, dropped it to box, and we have successfully connected back to our C2 server on the internet. And we have an SSH tunnel connected there, and that's on the same host as before, with AV EDR installed. So moving on to file restrictions, there are some characteristics of how the file system works which can be helpful to us as an attacker. If a file is not readable in Linux, it may be possible to read this file from Windows, as we touched on earlier. So files can be accessed using the File Explorer, WSL.localhost, followed by the distribution name, will give us the distribution root directory, and then we can browse to the directory of choice. Here, I've just viewed the shadow file in Notepad. As a low-privileged Windows user, obviously as a low-privileged Linux user, you wouldn't be able to do that. So there are some differences in user restrictions both sides. And if we wanted to, we could take the hash there and crack it offline and pray and hope that the user has used their password for the Windows user as well. If we wanted to build this out then, some tooling to harness WSL, one way we could do that effectively is using WSL API, which we touched on earlier. This is a Windows API, and these are just a couple of the functions here, which could be useful. So we can check if a distribution is registered. We can launch that distribution with a command interactively, and we can even register distributions ourselves. So we can either register default distributions or custom distributions, and it is possible to build your own custom distribution. The default distributions are, fairly standard: Ubuntu, Debian. I think there's even a Kali installation you can use if you wanted some attacking tooling. And so with that in mind, I've done a small proof of concepts just to see what this looked like and execute the who am I command here, as you can see on the right hand side. And this gives us the ability to execute Linux commands or local binaries programmatically. And I've compiled that as a Windows executable, but that's using WSL API. And you can see here, so it checks the distribution exists, it runs the command and then prints us the output. And that's using WSL launch interactive function, and written in C++. Very basic example, but if we wanted to modify that slightly then to match the scenario we talked about earlier to gain C2 control, then we could use that to run a local binary, Chisel binary, ELF binary in the same directory, and that will execute the local file, which then reaches out and connects via SSH to our C2 server. So again, very basic examples, but better programmers than I will be able to use that to good effect. So we're going to talk about visibility and telemetry a bit here. When we talk about viz and telemetry, we are speaking about how a defender might be able to track our activities as attackers, and how that might impact what we choose to do on target or what we choose not to do. And And it's always important to keep OPSEC in mind as a red teamer or even as a pen tester. If you're trying to get the job done with minimal resistance, it's a good idea to have some idea of the consequences of our actions on target. So Windows event logs. Native Windows logging can offer some visibility into the activity we conduct through WSL. However, there are some differences in versions. Sysmon can log process creation and command line events executed by the user in version 1, and version 2 is a slightly different story, as you see on the next slide. So on the left-hand side here, we've got, apologies, that's quite small. I'll explain it, but we've got WSL run as a single command, user just running who am I. And you can see that the command line argument has been captured. And then on the right-hand side, we've run that from an interactive session, and no command line arguments have been captured there. So it will log process creation, and it will show when new processes are created, but you won't be able to see command line arguments, which can afford us a little bit of movement when we're operating and trying to stay as stealthy as possible. Same view from EDR telemetry then. On the left-hand side, it's a different command, but it's the same concept. We've used curl to reach out to a host on the local network and grab a download file. On the right, we can see the process tree there. We can see that we can even see the command that's been used. On the right-hand side, from an interactive session, all we can really see is the network traffic. So it's just a little bit of a difference in logging capabilities when using it on the command line or interactively in a shell. We're going to touch on a couple of points of interest and considerations, which I think I just have time for. So restricting access. If you can't view the file system from Linux, the Windows file system from Linux, then it might be because of this. It's possible to restrict access to the file system using auto mount, and this is done by placing a conf file in the etc directory, and by setting that to false, it will prevent auto mounting of the Windows drive. We can also prevent Windows processes from running from within Linux, and that's done in the interrupt settings there as well. Some network considerations to make, just quickly, is the default mode is NAT-based. Okay, so you're going to be, if you're in a default distribution, you're going to be using NAT-based networking architecture, which is not ideal from an attacking machine within a local area network or an enterprise environment for obvious reasons. However, mirrored mode networking does exist, which is a feature which allows you to connect to WSL from the LAN. So if that's configured, then you might have some more maneuverability there. And this also offers IPv6 support. There's a DNS tunneling feature which uses a virtualization feature for DNS requests from within WSL without having to configure individual host names to IPs, and then auto proxy, this is an important one, is that if auto proxy is enabled, then this will take Windows HTTP proxy information, so system proxy information. In an enterprise environment, if you're up against Zscaler, something like that, and you're using, and the environment you're in is using that as a proxy, then auto proxy will force WSL to use the same system proxy settings as Windows. So just want to know. And then lastly, persistence. Much in the same way we would get persistence on a normal Linux host, we can create or modify systemd services to repeatedly execute malicious payloads as part of persistence. This isn't possible in WSL version 1 as we don't have full virtualization, we don't have systemd in it, but we can still demonize WSL processes to set them as persistent processes, but there are some limitations to this, which I don't really have time to go into, as I think I'm on time. And that brings us to a close. So some further reading, if you want to look into logging specifically, this white paper here at the top by Amanda Drager is really good, covers some in-depth logging capabilities for WSL. The WSL documentation for the API, and then the manual install steps as well there. And that brings us to a close. Thanks very much for listening.